Alright everybody, welcome back to another video. In the last part we introduced some spores that the player can eat, but at the moment they can just eat the spores and they don't grow, and there's no sort of competitive aspect to it because the players can't measure themselves in any way to say I'm bigger than this player or anything like that. So in this part we're going to be incorporating some of those scoring mechanics by allowing players to eat spores and grow, and then once a player is sufficiently large, if they eat a smaller player, they will also be able to grow and basically send that smaller player to the shadow realm. So here's a little sneak peek into what we'll be achieving in this video. So you can see I've got one player in the game already. He's able to eat the spores and grow as such. And you might also notice, if you're paying attention, that the spores are actually replenishing on the map. So we should see them popping into existence just so that the server doesn't run out of spores. And if I register as someone else, I should be able to find, there he is. Let me just swap the windows around to make it a little bit easier to make these players meet. And if I run into the larger player, I should get eaten and respawn somewhere else on the map with a smaller radius than I had before. And the bigger player will also grow accordingly. At the end of the last video, we left off with the player eating spores and telling the server about it, but the server isn't doing anything with that information. So what we want to do is actually get the server to validate if the player's actions are reasonable. So if the player could reasonably have eaten the spore that they are saying that they did, and then either accept or reject that claim. This way, we are performing some server validation to make sure that the client is not hacking or cheating in any way and gaining an unfair advantage over the other players. So I will show you in this lesson how to do that on the server side, some of the techniques that we're going to use to do that. And we're going to start by simply coming to the server and opening up the in-game state. And we're just going to revisit the handle spore consumed method. So at the moment, we're just logging this information. Let's actually do something with it. So basically, this handler method is going to have to check a few things. So number one, does the spore actually exist? Number two, was the player anywhere near the spore that they said that they ate? And number three, if the player did eat the spore, how much should they grow? And then we can figure out the growing logic after that. So to address the first one, does the spore actually exist? We can just make a helper function to grab a spore with a given ID and return that spore if it exists. Otherwise, we can return an error. So let's go ahead and make this method, and we'll call it get spore, and we'll give it a spore ID. And it's just going to return a spore object along with an error potentially. And we can easily just look this up using our handy shared game objects spore collection. And then we'll just say if not exists, return nil for the spore. And we'll create a new error here called spore with ID does not exist. Otherwise, let's just return the spore along with nil as the error. So this is really just more of a convenience method instead of this. So it's going to actually return an error for us, which is going to be useful in a moment. Another method here, so all of our validation methods, we're going to make return an error potentially. And then inside of our handlers, where we're doing the validation, we can check for these errors. So the next concern is whether or not the player was anywhere near the spore when they said that they ate it. Obviously, if the player is on the other side of the map and they're saying that they're eating all the spores, we can easily just check the distance and we can easily tell whether or not the player is lying about that. We don't want to be too strict though, because synchronization between the server and the client is never going to be perfect. So we don't want to punish the player if they're on a little bit of a shaky connection or if our server code isn't 100% accurate. So we can just check to see if it's within a certain buffer radius. So we'll call this method validate player close to object. because we can reuse this method later when we are checking to see if a player is eating another player. So we'll give it an object X and an object Y, as well as an object radius, and these will all be floats, and we'll let it return an error if the validation check failed. So basically what we're looking to validate is, in this scenario here, if this left circle is the player, and this right circle is a spore, and the distance between the edges of the circles is the buffer, then we're just interested to see if the distance between the player and the spore is less than or equal to their combined radiuses plus this buffer distance. So let's check that. First we'll check the actual distance. So we'll get the distance in X and the distance in Y, and we can calculate the real distance squared. So if we were looking at the actual distance, we would have to take the square root of this because of the Pythagorean theorem. But just because square roots are a little bit expensive, we're just going to avoid that by storing this as a distance squared value. So that's a pretty common technique that you'll see a lot. And let's also grab the threshold distance. So this is just going to be the combined radius of the player, as well as the spore or the object. And we'll throw in the buffer distance there as well. And we should probably supply the buffer as an argument to this method. So yeah, this is referencing that diagram that I showed you just before. And let's get the threshold distance squared so that we can compare it against the real distance squared. So if real distance squared is greater than threshold distance squared, then we know that the player is too far away. And we can even give a little bit of information here. So distance squared and this threshold squared, just so that we can see in our logs if this looks reasonable. But otherwise we'll return nil if we are within that distance. And to address the third question we had for this handling of consumed spore messages, how much should the player actually grow once they've consumed a spore, or if they've consumed another actor or something like that? So basically what we want to do is we want to absorb their mass. So if we treat these players sort of like as 2D circles, we can just say that their mass is equal to their area, or at least proportional to it. So if the bigger player consumes the smaller player, or if it consumes a spore, that spore will be absorbed by them. Their mass is going to be increased, and also their radius is going to be increased by some amount. So it's our goal to calculate how much the radius increases by. So we can just do a bit of basic maths for this. So let's just assume that the player's original radius before they consumed the spore was R0. And let's just say that their original mass M0 is equal to pi R0 squared. So this is just the area basically. And let's also assume that the spore's radius is R. So their mass will be M equals pi R squared. So when the player eats the spore, we absorb their mass. So the new player mass is the original mass plus the spore's mass. And to find the new player's radius, R1, we just need to solve this equation. So new mass is pi R1 squared. Well, we know what the new mass is, it's this. So we can replace M1 with M0 plus M. So that's what we've done here on the left-hand side. And that's still equal to pi R1 squared. We can divide by pi on both sides to get this, and then just take the square root on both sides to arrive at our new radius to be the square root of the old mass plus the spore's mass divided by pi. So we'll make a new method to calculate the radius based on the mass using our newfound knowledge. So mass to rad, and we'll give it a mass, and we'll output a radius. So we're just returning math.square root mass divided by math.pi. So if we pass in the old mass plus the spore's mass into this function, we will get that formula that we saw before. And just for convenience sake, it would be pretty nice to have a little helper method to convert a radius to a mass. It's just going to perform the pi r squared calculation for us because we're going to have that a few times in the code. So rad to mass. So this will just be the inverse function. So let's go and use these methods. We'll create a new method called nextRadius, and this will be the radius after we've consumed some new mass. So this mass diff is going to represent like the mass of a spore or the mass of a smaller player once we've eaten them. So we're just going to say old mass equals rad2 mass with our radius, and then new mass is the old mass plus the mass difference, and we'll simply return mass to radius of the new mass. Oh, and I made these methods, but they should really just be static functions. So I'll just get rid of the that syntax trigger. So these are just functions, really. So these are just functions, but this one is an actual method. All right, we can actually put this all together now. So in the handle spore consumed handler, we can fill this method in now. So let's go ahead and do that. These are all the validation checks put into one place. So first of all, if this was actually broadcasted to us, meaning it came from another client after the validation checks were performed on their end, and they're trying to tell us about it, we can send it straight to our client. So we can trust that this happened. So if sender ID is not equal to our ID, then we can just g.client.socket send as, and we'll just forward the message onto Godot like that. Otherwise, if this came from our client, we need to actually validate what they're saying happened. So if the spore was supposedly consumed by our player, we need to verify the plausibility of the event. So we'll just be kind of pessimistic and set up an assumed error message called could not verify spore consumption. And here we're going to tack on a reason if we get an error from either of our checks. So first, check if the spore exists. So we'll grab the spore ID from the payload, and then we'll just use our helper method. So spore and error is g.getSpore. If error is not nil, g.logger.print line error message plus the error that we got from here. And in that case, we will also return from the function because we know there's no point in continuing. So this is the first and easiest check. So it's important to do the easy checks first so that we're not crunching through server resources. Because if we did the next check, because it involves a little bit more calculations, this is best to be saved for last. Next, check if the spore is close enough to be consumed. So we'll just check error equals g.validate player close to object, and for the objects x, y, and radius, we'll give those of the spore, and we'll just give a buffer of 10 pixels. If error is not nil, then we'll go ahead and do the same as what we did up here. If we made it this far, the spore consumption is valid, so grow the player. And we'll also remove the spore and broadcast the event. So we're simply going to grab the spore's mass using the spore's radius and our little helper function. And now we're going to set the player's new radius. So g.player.radius is now going to be g.nextRadius with the spore mass as the mass diff. So we're going to remove the spore from the shared collection in the background, just in case the collection is locked. We're not going to wait around for it. We don't really care that much about the output of this. We're just going to say that we want to remove it, basically. And finally, we will broadcast the event. So this is our validation for consuming a spore. It's pretty simple. Most of it's just error checking. And we'll broadcast the event if and only if it passed all the checks. And if another client receives that broadcast event, it'll forward it straight to Godot. So that means we're going to have to go and process the spore consumption on the client side. So let's come back to Godot, come to our ingame.gd script, and let's look at our WebSocket packet handler. And let's add another kind of packet that we are going to check for. So elif packet.has spore consumed. handle spore consumed message. And let's define this new function down here. So what are we going to do on the client side when we receive a spore consumed message? And we know that it's already been validated on the server side, so we can trust that this is legit. What we're going to do is we'll just update the player's size and remove the spore from the game. So if we're going to update the player size, we'll need to get them from our list. So if sender ID in players, and because sender ID is the ID of the person who originally sent this to us, because we're forwarding the sender ID, it's being preserved. That's why we're interested in grabbing them from our players dictionary. So actor is players, sender ID. We can grab their mass. So because we're going to need to grow the player, we're basically going to need to do a similar calculation to what we did on the client side, with the same maths is going to be involved. So we're going to define a similar function in a minute, but for now let's just pretend like we've defined it. So we'll get the actor mass equals rad to mass actor dot radius. So let's just define that just down here. So this is just the same function that we defined in Go, but just using GD script. All right. So back in our spore consumed message handler, let's grab the spore ID so that we can grab its radius as well. So we'll grab the spore ID from the messages payload, get spore ID. If spore ID in spores, now we can actually grab the spore object and its mass. Finally, let's call a function that doesn't exist yet, but it's going to be called set actor mass. Provide the actor and the new mass, which is going to be actor's mass plus spore mass. And then we will clean up by removing the spore. So we already have this function, remove spore. So we'll use that. Okay, so we just need to define this function now, set actor mass. And why not just put that down here? So it's going to take in an actor and a mass. Call it new mass just to make it clear. And we're just going to use the same calculation we found before. So actor.radius equals the square root of the new mass divided by pi. So let's go ahead and run the game. So I'll just run the server. And I'll run the client. Let's log in. And let's eat some spores. Alright, we're eating all the spores, but we don't seem to be growing. So why is that? Well, it turns out we've actually missed one key detail, which I might have alluded to in the last episode. So remember the draw method in our actor? This draw method that we've overridden here. If we look into it, it says called when the canvas item has been requested to redraw, either manually or by the engine. So basically what it's saying is we need to actually request redraws manually ourselves every time our actor's changed, i.e. if our radius has been updated and we want to update what our player looks like, we need to call this queue redraw method. So let's figure out the best place to do that. Well, basically anytime we update the radius, we want to queue a redraw. And we could go through our code and find all the places that we're updating the radius and then be really careful to make sure in the future that when we change the radius, we also do a queue redraw. We could do that. Or we could use a setter in Godot. We have something called a setter. So a setter is basically just a special kind of function which is attached to a property such as radius. And this method will get called every time this property changes. So if I type actor.radius plus equals 1 or actor.radius equals 5, then whatever we define our setter to be, it will get run guaranteed. So this is a really great way to ensure that we don't shoot ourselves in the foot. It kind of forces us to remember to do these things instead of having to remember ourselves. So the way you define a setter is you just put a colon after the property line, and then you just type the word set, and then you give a name to the new radius, and then another colon, and then here is where you type the code that you want to get run. So obviously, well, it might not be obvious, but you do actually need to set the radius equal to the new radius. It might seem like that would be done for you, but you actually do need to type this. And then we can go ahead and do Q redraw. But another good reason to do this is because we're also neglecting another thing, which is we need to update our hitbox every time we grow. So before we redraw, we should actually do this as well. Collision shape dot radius equals new radius. So now if we run the game, we should see that we're growing in size every time we eat a spore. And we can trust that our hitbox is also going to be scaled appropriately. Yeah, cool. So we can see that we're actually growing. And we're only doing this because the server's telling us to. There's nothing in our code that says when we collide with the spore, we should grow. The only time that we're growing is when the server says that it's okay to. So this automatically means that we are passing the checks. And if we look in the server logs, they look clean. So all of our validation checks are passing. We can put it to the test. Let's hack our game client and see if the server complains. So maybe in the actors instantiate function, whatever speed we receive, let's just say that, let's set our actors speed to be twice that amount. So this will be like a speed hack. Let's see if that stops us from actually passing the validation checks. Well, one thing we're seeing is we're always getting snapped back by the server. So, I mean, that's kind of saving us in this case. Let's see, what if we did like a collision, like a radius hack or something like that? Let's see if let's just set new radius to be double. So we grow twice as fast as what we should. And that means we should be able to reach more and more spores. Let's see here. Oh, here we go. Yeah, we're getting a bunch of errors and we're not growing. So could not verify. Obviously, I've got a typo here. I'm just going to fix that up. Yeah, could not verify spore consumption. Player is too far from the object. And you can see, yeah, we're more than the threshold distance allows. So that's why we're failing these checks, because we are literally twice as big as we should be. So the server's like, nah, that's not possible. It's not possible that you could have consumed that spore if you were the correct radius. So it looks like to us that we're actually still eating these spores, but if we looked at it from the perspective of another client, we would see that we're not eating the spores at all. It just seems that way to us. So if you look on the right here, if you keep an eye on Tristan, all the spores that he's running into are not getting eaten from the perspective of John. So, you know, he thinks that he's eating the spores, but we don't really care what he thinks because he's clearly hacking. As long as the player experience for other players looks fine, that's all we really care about. So I'm just going to remove that line, the little hack. Okay, so the spore consumption logic and the growing logic is looking really good. Now onto eating players. This shouldn't be too much more work because we already have the concept of as. Players can see themselves and their opponents grow. So now it's just logical that we should add the concept of eating other players. So implementing this will be very similar to what we did with the spores, but we're just going to have a couple key differences. So you can only eat another player if your mass is more than 150% of their mass. And when you eat another player, you'll gain their mass and they will respawn at a random location with the original starting mass. So let's get to work on this. We'll just need to define some new packets. So let's do that in our shared/proto folder. We'll make it, maybe you can guess, player consumed message. We'll give it a player ID and add it to the list. Don't forget to recompile. Now back to the client. We are going to revisit our ingame.gd. We had a onPlayer area entered handler for the area 2D signal. And we have a check to see if the area was a spore, but let's add another check to see if the area was an actor. Collide actor area as actor. So notice we're calling this collide actor rather than consume actor. because we don't know whether we're on the consuming end or the consumed end. So that's something that'll be determined by this function here. So we'll define that right underneath consume spore. So we're going to need to compare our mass with the mass of the actor that we're colliding with. So we'll need to grab a reference to our own player. So player equals players, because we are also in this dictionary. So we can just look ourselves up with the game manager dot client ID, and then we can grab our mass. So we'll use rad to mass player dot radius, and let's grab the other actor's mass. And now we can just check. So if the player mass is greater than the actor's mass times 1.5, this means that we were bigger than them, so we're going to call another method called consume actor. So let's create that method as well. Consume actor. We'll grab another reference to our player here, because we're going to need our mass again so that we can actually grow. So we've got a little bit of repetition here, but I think it's fine. This is not something that happens all the time. So we're going to grab the actor's mass as well so that we can use that in our calculation for how much we need to grow. And then we'll simply set actor mass. This is the function that we wrote just earlier of our player. And the mass is going to be the player mass plus the actor's mass. And then we need to tell the server that we have done this. So we're going to create a packet, create a new message from that packet, set the player ID on our new message. So this is the ID of the player that was eaten. So in that case, that'll be the actor. Send that off. And finally, remove the player. So we don't have a function for this yet, but we'll make one in a second. And we're going to remove the actor that we ate. So let's define this just down here, underneath where we've got the remove spore method. And I think you could probably guess how this is going to go. It's just going to be players.erase actor.actor ID, and then actor.queueFree. All right, so we are equipped to collide with an actor, tell if we are the ones that should eat them. And if that's the case, we can go ahead and set our new radius and then tell the server that we've eaten that player and then remove them. So that means we need to expect a player consumed packet on the server. So let's go ahead and do that on our ingame.go. We'll just add a new handler to our handle message method. And then we need to define handle player consumed. We'll do it just underneath where we defined handle spore consumed. These methods are going to look similar. So first of all, if this was sent from someone else, we need to make sure we handle that. So basically we just need to tell the client about it, and then we need to respawn the player that was eaten. So we'll firstly g.client.socket send as. You can do this in the background as well using a Go routine. And then we just need to do if the message.player consumed player ID is our player ID, then we were the ones that got eaten. So we'll just do a little log. Player was consumed respawning, something like that. g.client.set state. So we're just going to reset the state basically. So we're going to recreate the in-game state, and the player is now just going to be a new objects.player with the same name, but everything else is going to be initialized on the onEnter method. And basically, yeah, if that happened to us, then there's nothing else for us to do, so we'll just return at this point. Otherwise, if this came from our own client, we need to validate whether or not this could be possibly the case. So if the player was supposedly consumed by, if the other player was supposedly consumed by our player, we need to verify the plausibility of the event. So we're going to go through the usual rounds. We'll set up a error message, just like we did in the spore consumption validation. And First, we'll check if the player actually exists. So we're doing the easy check first. So we'll call this the other ID, and then we'll try to grab them. And we're going to create a new function called getOtherPlayer. So this is just going to be pretty much the same as the getSpore function. So I'm just going to copy and paste it. So I'm going to call it getOtherPlayer, and instead of spore ID, we'll use player ID. And instead of checking in the spores collection, we'll check in the players collection. Modify the error message, and then return player. And we're also returning an objects.player. So I could probably do a better job making this a bit more general, but for now it's not too much of an issue having a little bit of code repetition. So let's come back up, and we're trying to grab the other player with this new method that we just made. And we'll just check if error was not nil. We will print our error message out and return. Next, we're just going to check if the player was close enough to be consumed. So we're going to reuse our validate player close to object method, and we'll give it a buffer of 10 as well. I'm going to exit early if there was an error on that validation check as well. And finally, we just need to make sure that the radius of the player who is saying that they consumed, we just need to make sure that the radius is sufficiently large as well. So if we, okay, finally check the other player's radius is smaller than our player's. So we just need to check if g.player.radius is less than or equal to other.radius times 1.5. We'll just log a message saying that player's radius not big enough, something like that, and we'll return as well. And if we made it this far, the player consumption is valid, so we'll grow the player and broadcast the event, and we'll also remove the consumed player. So we'll just grab the other's mass, so we can use that in our calculation to grow our player's radius. And then we'll remove the other player in a background Go routine, and then just broadcast the event. So yeah, it's pretty much the same as the validation for a spore, with the exception of respawning if we were the ones that got eaten, and having this extra check just to make sure that we are sufficiently large to do what is being said. So let me rerun the server, and we'll just check if it works. This might be the trickiest part, is actually getting two players to meet, just because the controls is not really well suited for one mouse, but I'll try my best. So we need to let one player grow pretty big. So I'll just collect a few spores here. That should be big enough. So now I need to find where John is, and then I can let them come to each other just by moving the windows around like this. So when I eat John, he should be removed and respawned to a random location. And there we see. So if I zoom out again, I should be able to see John in his new location. Oh, yeah, I see. So I should actually maybe be able to eat him again. Nice. All right, looks good to me. If I was to play the game long enough, I would probably notice a couple issues. Number one, it's actually possible for players to respawn inside of other players, which causes them to get eaten immediately. And obviously that's not a very fun user experience, so we'd want to try to avoid that. The other thing too is that spores do not respawn, so once they are eaten, they go into the void, never to be seen again. And if the server was running long enough, eventually there would be no more spores to eat, so that wouldn't be a very fun game. So just before we finish things up today, let's address those two issues. Starting with the respawn logic, you might recall we made this objects/spawn.go file in the last part, which is currently just doing pretty much nothing. This is probably the most basic spawn coords function you could get. So let's flesh that out a little bit now to make it a bit more enjoyable for the players, so at least they're not spawning into each other. So let's actually give this thing some parameters. These are going to be optional parameters, which you can supply if you want to avoid certain things. So if I wanted to get some spawn coordinates, but I wanted to avoid players, I can pass in a players to avoid collection. Or if I wanted to avoid spawning on top of spores, I could pass in a spores to avoid collection. And this should go ahead and give me some coordinates, which are guaranteed to not be inside a player or not inside of a spore, depending on what we supplied. And to make that work as well, we're going to need to give it our radius. So the first argument is actually going to be our radius. And then we're going to have players to avoid, which will just be a shared collection of player pointers. And because we're in the objects pattern, we don't need to type objects.player. We can just type player. And let's also give it a spores to avoid. All right. So instead of just spawning random coordinates, let's be a bit more thoughtful. So let's naively just go ahead and try x is going to be bound times 2 times rand.float64 minus 1. So this will give us a random number between negative bound and positive bound. And let's do the same with y. And this is just going to be our first guess as to the spawn coordinates. But we'll see if this was sort of too close to a player that we want to avoid, or if it was too close to a spore that we want to avoid, then we're basically just going to try again. And we'll do this until we run out of tries. So we'll have sort of like an attempt budget. And if we exceed that attempt budget, then we are going to increase the bound. So basically increase the search radius for a place to spawn. So let's incorporate that. I'm going to say const max tries will be, let's just say 25. And let's just set a counter for the tries. So we'll set that equal to 0. And we'll do this in a for loop or an infinite loop. So we'll try to get a suitable x and y, and then we'll just check. We're going to define these functions in a minute, but we'll say if not is too close, x, y, radius, players to avoid. And the is too close function is going to need to know how to get the position and the radius of the thing that we want to avoid. So we're going to need to supply a couple functions that don't exist yet. But we'll also supply these. So this is going to be an argument called get player position, and this is going to be get player radius. And we also need to check as well if not is too close, xy radius, spores to avoid. And we'll pass in some functions to tell the is too close function how to calculate the spores position and the spores radius as well. So if that's the case, then we can simply return x and y. Otherwise, if we were too close to one of these things, we're going to increment our tries counter and then check if the tries is greater than or equal to max tries. We are going to increase our bound by doubling it and reset the tries counter. So that'll force us to go back into the loop and try again, but this time with a bigger search bound. So now we just need to implement these 4 methods as well as this method here. So I guess it'll be easier to implement these guys first. So these are just going to be one-liners, pretty simple. Get player position. It's going to be a function that takes a player and returns the x and y positions. And we're simply going to return players x and players y. So let's do get player radius as well. So that's just going to return a single float, and that's going to be the player's radius. And let's copy and paste these and write pretty much the same thing for the spores. All right, so with that out of the way, now let's tackle the is too close method. Is too close, and because this can be called with either players to avoid or spores to avoid, we're going to let it take in a generic parameter just to keep things general. And it's going to take an x and a y, a radius, as well as objects. So these will be the objects to avoid. That'll be a shared collection of t. And we need a function to get the position of whatever we are trying to avoid. So that'll be a func that takes in a t and returns a pair of floats. And the get radius function as well will be a function that takes in a t and returns a single float. And this whole thing is going to return a boolean, whether or not we're too close to one of those things. So I guess the first thing to check is if the object was nil, then we're just going to return false, because if there's nothing to check, then we're not too close. So not too close if there are no objects. And then we just need to check if any single one object is too close, we're going to return false. Check if any object is too close. So we'll set too close equal to false to begin with. And then we'll just loop through each object. And we need to give the callback function. And we don't need the ID. We're only interested in the object itself, which is going to be of type t. So if too close, return. So this is basically just saying, if we did find that we were too close, when we want to return, we're just going to be returning from this callback. So then every time we loop through the callback again, we're just going to keep returning if we were found to be too close. That just saves on a bit of computation. And we'll get the object's x and y position using the get position function that we passed into this function. And we'll do something similar to get the radius. Now we can just calculate the distance. So x distance is the object's x minus our x. And same thing for y. And then we can go ahead and get the squared distance between us. So that's the x distance squared plus the y distance squared, just Pythagoras. And then if the distance squared is less than or equal to the combined radius squared, we'll just say too close equals true and return. So yeah, this is what I mean. Like this will just return from this callback, which means it's going to go back in again because we're doing this for each loop. So the best we can do is every time we return, the first thing we're going to do is check if we're too close, and we'll just keep returning until we run out of things to run the callback on. So it's not ideal, but also not the end of the world. And finally, we'll just return too close. Okay, so that's our too close method. And this completes our spawn chords function. So what we can do now is update wherever we've used the spawn chords method, which luckily is just in one place. This is just in hub.go at the moment. So this is where we're spawning the spores. So in the new spore method in hub.go, we've got xy is objects.spawn chords with no arguments. We're just going to change that to give it the spore radius. And let's just say we want to avoid both players and other spores, because obviously we don't want new spores spawning inside players, because that could cause them to just grow. Like imagine if the player is already extremely big, like the size of the map. And if we're spawning all of our new spores into this player, obviously that's just going to cause them to balloon. I'm aware that this is currently we're only spawning spores at the start, but we're going to reuse this method to replenish our spores as the game progresses. And we're also going to sort of avoid existing spores as well, just so they don't clump up. All right, so that's for spawning spores. And for spawning players, we can come into the ingame.go. And at the moment, we're just doing a really basic onEnter method. We're just setting the x and y to a random float between 0 and 1000. So let's fix that and say g.player.x and g.player.y equals objects.spawn chords. Let's give it the player's radius, because that's required. And we want to avoid players. And we don't really need to avoid spores. We're not really interested in that. It might be kind of difficult to avoid spores. So we'll just keep it simple and supply nil for the spores to avoid parameter. So if I run the server now, we should still be able to spawn in no problem. And it'll be kind of difficult to notice, but we should be able to trust that we are spawning in a much more thoughtful way. So if another player joins, they should also be avoiding us. I'm really just checking that we have no errors, because it's kind of impossible to test something like this. Well, you could test it by making one player pretty much as big as the map, but yeah. Well, the last thing we wanted to do today was make sure that the number of spores on the map stays more or less consistent. So we want the number of spores to always hover around 1000, no matter how much they get eaten. So we can achieve that by running a loop on the hub that checks roughly how many spores are missing from the shared collection. And we'll just run this every few seconds. It doesn't have to be super accurate. And if there's any missing, we can just add them back. So let's come back to the hub. And let's actually add a new method to the hub struct, which will do this. So we'll just find a good place to put this. I guess we'll just put it at the bottom. So this is going to be a method on the hub, and we'll call it replenish spores loop. And we'll give it a rate, which is how often do we want to do this? So we need to import time. I'll just press Ctrl S and let VS Code do that for me. So we're going to create a ticker for the given rate. We'll defer stopping the ticker. So this should look pretty familiar to you. This should look pretty similar to the player's, sync player loop, I think? Player update loop. Yeah, so we're pretty much going to be using the same structure here. But we're not going to need to worry about having a cancelable context, because once the hub is finished, everything else is going to be finished as well, so we don't need to worry too much about that. So for range ticker.c, so this is just a channel that triggers every time the ticker ticks. So we're just going to be listening on that channel. So we'll just calculate the spores remaining. h.shared game objects dot spores. We can finally use the length function. So we haven't used this one yet, but it just gets the approximate number of objects in the map. So that's perfect for what we want to do. We'll get the difference. So that's just going to be max spores minus the spores remaining. And we'll just check if the difference is pretty much none, we can just continue. There's nothing for us to do. Otherwise, we can just log a little message to say we're going to replenish. This is just to help us make sure that this is actually working. So we're going to replenish X spores, where X is the diff. Also, we don't really want to spawn too many at a time, because it could cause like lag spikes. So let's just make note of that. So I guess if there's lots missing, we'll just replenish like 10. So, and then like the next time we run this loop, we can do the rest. So it's not really, we don't need to worry too much about it, because this is going to be running every few seconds anyway. So eventually all the spores are going to be replenished. It might just take a little bit longer, but it's not really going to be an issue for us. So we're going to do this, whichever one is smaller, the diff, so the spores to replenish, or 10. And we're going to make a new spore. So that's this function here, which is why we were using the spawn coords, avoiding players. So we're going to make a new spore, grab the spore ID. We're grabbing the spore ID by adding it to our spores shared collection, because remember the add method will return the ID of the thing that you added. And then we can just broadcast the spore. We're actually going to access the hub's broadcast channel. And we're going to put into it a packets.packet. Sender ID is going to be 0, which is going to be a special reserved sender ID to mean this came directly from the hub. And the message is going to be packets.new spore, spore ID, and spore. And we might as well just sleep a little bit to avoid a lag spike. If this is something we need to be worried about, I'm not too sure, but it doesn't hurt. We're going to be running this in a background thread anyway. Oh, and I just want to make sure this is a printf instead of a print line. All right, so let's go ahead and actually run this in a Go routine. So a good place to do it would be in the hub's run method. And we can just choose to do that maybe after we place the initial spores would probably make sense. So we'll go h.replenish spores loop, and we can do it every 5 seconds. We could do it every 2 seconds. doesn't really matter. You're free to play around with these values. You probably want it to be more than 1 second at least. You don't want to be doing it too often because it's kind of unnecessary. It's not like players are going to notice. So because we are broadcasting these new spores from the server, we need to make sure that we're handling that in the in-game state. So we'll come to ingame.go. We will find the handle message method. And let's just make sure that we are handling spores. g.handle spore, sender ID message. So let's just define that down underneath where we're up to. All right. So what do we want to do? Well, it's pretty simple. We're just going to send it to the client. Okay. On Godot, we're actually already handling these spore messages because they come from the server to begin with when we initialize a new player. So yeah, we're actually all good to test this out. So I'll run the server. And yeah, as long as you didn't remove that line of code here, packet.hasSpore, handle spore message, if you did the optional section in the last video, just make sure you still have this line here. You might have been tempted to remove it, but let's go ahead and run the game, and we'll see if we can spot any spores replenishing themselves. Might be pretty hard to spot. Well, maybe we can look in the server logs actually. Yeah, so we can see 997 spores remain, going to replenish 3 spores. And if I eat a few more, we can see 998 spores remain, 999, 998. So it is definitely running. It is definitely detecting that spores are missing, and it's saying that they're replenishing them. Oh, I think I saw one pop in. Yeah, I'm definitely seeing spores pop in. So that appears to be working. All right, so that's it for this video. We've successfully allowed players to eat each other and they can grow. This is all validated by the server as well. So if clients are trying to hack their game, the server will just flat out reject those things and they're going to have an awful time. We've also addressed some of the issues to do with the spawning and the spore replenishment. So now things are always going to spawn in a really sensible way, and things are going to be replenished so that the server always has a constant, more or less, number of spores on the map. So it looks like we have all the elements of a competitive MMO, and we're well on our way to having a complete game. In the next part, we're actually going to add a high score system to the game so players can compete to be the best. But until then, thanks for watching. Leave a like on the video or leave a comment if you had any questions. And don't be shy to join the Discord channel. The link will be in the description. Until then, I'll see you in the next part.